Hey everyone, so let us move on to the next question, that is finding permutations of a string. Okay, so I know you must have studied about permutations, but let us discuss how we can write a code that can generate all permutations of a array or of a string. So let's see this input. So we are given this input and we know that this string has 3 letters, so we can form 3 factorial, that is 6 permutations. Okay, and we need to print all the 6 permutations that we can think of. So let's see how we can solve this problem. So let us say we have this input string abc, and the way to break down this problem is how we can generate permutations. Okay, so the most fundamental way of finding the permutation says that, okay, we know we have a at the first place. If I can find out permutations by putting b at the first place, okay, so what I can say, okay, let us have a at the first place and let us try to find permutations of the smaller string, that is bc. That could be one path. Another path could be, we can say, okay, no, let us put b at the first place and let us try to find permutations of the smaller string, that is ac. So we swap b with a, or we can do, okay, maybe let us swap c with a. C comes to the first place and let us try to find permutations of the smaller string, that is ba. Okay, and if you do the same thing for the smaller string bc, you can get abc, or you can get acp. You do the same thing for this, you get, either you have a at the first place, you get bsc, or you have c at the first place, you get bca. Similarly here, either you have b at the first place, you get cba, or you have a at the first place, that is cab. Okay, so you can see you got 6 such permutations. Okay, so I hope you're getting little bit idea. So what I'm trying to say is, if you have a string like this, if you have a letter, some letter l here, and you have some letters here, you try to exchange this letter with every possible letter in this particular string and solve the subproblem. How do you solve the subproblem? By making a recursive call. Okay, so maybe if I have a b c d e here, you swap l with a, l with b, l with c, l with d, l with e, l with f, and you get something like this: a followed by l, b, c, d, e, f. You make a permutation call here. Similarly, you get a b here, you permute this, you get a c here, you permute this, and so on. Okay, and this will again follow the same recursive structure that we are going to see. Now let us try to dive in a little more detail and try to understand the importance of backtracking and how recursion is going to work in this particular case, and then we will jump into the coding part. Okay, so if I say I have abc here, okay, first I will place a, I will replace a with a. Okay, I'm going to put a, or I'm not going to make any change, I'm just going to make a recursive call on the smaller part. So I come into this branch, I say, okay, I have bc here, and I again start doing work at b. I say, okay, I will put b at the same place, and in the next call I will replace b with c. So I get a, b, c, and I come to this. So now I have only one letter, maybe I can replace c with c. I come here, abc, and I go to the next position, that is null. That forms a base case. I come back to the previous call, and from here I come back here, and from here I say, okay, replace b with c, it becomes acb, and I make a recursive call on this one. Then I say, okay, maybe b with b, acb, and I make a recursive call on this one. Okay, I come back, I come back, and I come back. Now one thing to note is, when you're coming back, and if you're maintaining the original array, if you're not duplicating your array every time, you're having the original array, then at this particular point your original array would have changed. Okay, so you had ABC, you changed it to ACB, and when you're coming back, if you're doing modifications in the same array, because arrays are passed by reference, okay, instead of having ABC here, you will have ACB. You will actually have ACB, and that can actually cause a problem. Let us see if we have ACB here, what problem it would cause. So we go here, it will have ACB, and next time what you do, you swap A with C, it becomes CAB, and from here you make a permutation like this, CAB, and you also make it like this, CBA. You come back, this original array is changed, it becomes CBA. You come back, this original array has changed, it becomes CBA. And according to the logic, what you were going to do next, you were going to replace first character with the last character. It would have become ABC again, and you would permute BC. Okay, it would become ABC, and you come back, it still remains ABC, and you do ACB, you come back, it becomes ACB. Okay. So we will see in the code, if we make this mistake, if we do not modify our array while going back, we will end up getting the wrong result. Okay, we will end up getting the wrong result. Okay, these are not the correct outputs. We are getting these two outputs repeated. Okay, what we should do is, we should actually, while going back, we should modify, or we should restore our original array while going back. Restore our original array while going back, and this step is called as backtracking. Okay, we will see how we can implement backtracking in the code, but now let us see with backtracking logic what we can build. We have ABC, we say okay, replace A with A, then replace A with B, then replace A with C, and permute the rest of the stuff. Let us do the first call. We come here, we have this sub problem, replace B with B. We come here, we have this sub problem, it is too small, it becomes ABC. We come back, it is ABC. We come here, we go here, we replace B with C, it becomes ACB. We have this, we have this. Now we go back, we say okay, we replaced C with B, sorry, we replaced B with B, so we replace again B with B. We come back, from this step to this step, what change did you make? You swapped B and C, you do the swap again. Okay, you do the same swap again to restore the original array. Okay, so let me just say what you did. You did a swap of A1 with A2. Okay, you do this swap again and you will get the original array while going back. Okay, so what it becomes, it again becomes ABC. You go back, it again becomes ABC. Now what you do, you replace A with B, you make a call on here. What you do, replace B with B and B with C, it becomes A, B and C. This call, it becomes A, C and B. Okay, and the next call will be A, C, B, A, B, C. Sorry, this should be like, I just made the wrong diagram here. This should be BAC and it becomes BAC and it becomes BAC. You go back, it is still BAC. You come here, A gets replaced with C, it becomes BCA. You make another call, it becomes BCA. You hit a base case, you print the answer also. Okay, every time you hit the base case, you have the permutation ready that you can print. you go back, you go back, you go back, and while going back, okay, so every time you go back, you undo the changes that you have made while coming to this step, okay, and again you go back, you come here, A get replaced with C, it becomes CBA, CBA, and CAB, go back, it becomes CBA, you go back, it becomes ABC. Okay, so every time you hit the base case, you get the right permutation. Okay, so this is how we are going to implement recursion along with a backtracking step to find permutations in the next video. Let's see how to write it in the form of a code.